bicarb must increase when CO2 goes up. Bicarb must increase when CO2 goes up, and as something we're going to quantitate as Le Chatelier principle, but look therefore at my diagram. When CO2 increases, pH must drop, there must be an acidosis, but bicarb must increase. Therefore, a point along here shows me that as I'm becoming acidotic, the bicarb goes up. Therefore, that bicarb going up came from CO2. It's CO2 that became the protons to cause the acidosis and the bicarb to go up. You notice that my patient, the bicarb, it was low. And because it was low, it was not just it was both respiratory and metabolic acidosis. So more to come on this, but it's something I want you to see based on the chemistry and a little bit more. So metabolic disorders and we'll follow bicarb because 80% of the CO2 travels as bicarb versus respiratory disorders, and there will follow PCO2 itself and the portion of gas be breathing. Well, in a nutshell, I'm going to tell you, we can say proton concentration is directly proportional to PCO2 related to bicarbonate. Essentially, we're dropping the water from our story, and I'm just saying that if there's high CO2, there's high proton. If there's low CO2, there's low protons. So CO2 and protons are directly correlated. And conversely, if there was high bicarb, I would shift the curve in that direction, the graph in that direction. Therefore, I would consume my protons. They would go down. Therefore, bicarb and protons go in opposite direction. Look conversely, if I lower the bicarb, there's less bicarb to grab protons. So, of course, more will go in that direction for the equilibrium. So there'll be greater protons when there's low bicarb. Bicarb and protons are always inversely related. Everyone is okay with using the equation right now? That still works? Yeah? That's going to be our baseline. It's going to be our baseline, reminding us, of course, respiratory disorders versus metabolic disorders and how they relate to protons. Just make sure, remember that pH in turn is inversely related to the protons. Well, one final point before we can really get started. And finally, let's look a little bit at the stoichiometry of the chemical equation. You notice CO2 plus water, we said, makes proton plus bicarb. So bicarb increases when CO2 increases protons and lowers pH, and vice versa. Now, is that compensation or is that chemistry? Zahir, I'm getting to you in a second. Is that compensation or is that chemistry, what I'm writing here? The fact that bicarb